Start by preparing your specimen in accordance with your test standard. Once you have trimmed your sample to size, you will need to remove the split mould. In some cases, it can be useful to apply a small amount of non-corrosive silicone grease along the groove of the two halves of the split mould to help reduce resistance. We recommend the use of PTFE silicone grease. If the specimen is stuck, use a disc the same size diameter as your specimen to apply even pressure when pushing. Be careful not to damage the specimen in the process. Now you have removed the specimen, you can place it on the base pedestal of the triaxial cell. If you are running an effective stress test, it is important you ensure the triaxial base has been completely de-aired. If you have not de-aired your triaxial cell, please see the link highlighted in the video. The link is also available in the description below. Assuming the base has been de-aired, slide a saturated porous disc onto the base pedestal. It helps to have a pool of water on the base to keep the stone saturated and avoid trapping any air as you slide the disc on. If you are not measuring pore water pressure or applying a back pressure, you may use plastic discs instead of porous discs. Now you have your triaxial cell ready, you can prepare your membrane. To place a membrane over a specimen, you will need to use a membrane stretcher. Start by checking your membrane for any holes by stretching it over some light. If OK, place the membrane in the centre of the stretcher and fold either end over. The suction ball will act as a vacuum, sucking in the air between the membrane and stretcher, making it easier to slide over your specimen. Position the specimen on the base pedestal. You can now place the membrane stretcher over the specimen without damaging it by using the suction ball. Once in position, remove the suction ball to release the vacuum. Roll both ends of the membrane off the stretcher. You will now need to secure the membrane in position with an O-ring using an O-ring stretcher. Slide the stretcher over the specimen and roll the O-ring down. Ensure the O-ring rolls onto the base pedestal and not onto the specimen. In some cases, you may wish to add a secondary O-ring to ensure the membrane is completely sealed. Another O-ring is required to secure the top of the membrane. Stretch another O-ring over the stretcher and place it on the specimen. You will need to do this before you put on the top cap. Place a saturated porous disc on the specimen and the top cap on top. Twist the top cap to avoid the drainage lead getting trapped when positioning the top half of the triaxial cell. Roll the membrane up over the top cap. Slide the O-ring off onto the top cap, being careful not to slide it onto the specimen. Remove the stretcher and fold the excess membrane down over the O-ring. You have now assembled your specimen for testing. Place the top of the triaxial cell onto the base and seal by screwing the locking nuts evenly. You may wish to apply a small amount of silicone grease on the O-ring to help avoid leakage. Position the cell in the triaxial frame. Open a path from the de-aired water tank into the triaxial cell. Ensure the bleed valve is open and fill the cell with de-aired water. Once it is nearly full, be ready to close the valve as water begins to flow out. Now your cell is ready. Adjust the ram and displacement sensor, ensuring you have enough travel length on the transducer to conduct your test. Complete a quick check, ensuring the correct valves are open and closed. If you are happy, you can begin your test.